Hi, good afternoon. Hope you are having a good time. I think it's the second day, probably technically third day of the conference, so might be a little bit tired and then overloaded with information, so I'll try to keep it simple. So I'm Asanka Abeysinghe, Deputy CTO and the VP of Architecture at WSO2. So my talk today is not about WSO2, but I'll give a quick brief about the organization that I work. So we are a technology company, and we provide a full stack of products that's ranging from API management into integration into the identity, and all products released as open source offering, licensed under Apache 2.0. And if you go to wso2.com, you can find more information. So what I'm going to do today is to share some of the concepts about a project that I was working for a year or so. It's more of an architecture concept as well as it's related to DevOps as well. So it connects basically the architect, developer, and the DevOps. So I'll go in detail during my session. So before jumping to the session, I'll give a quick introduction about myself. So I born in Sri Lanka. I don't know how many of you know about Sri Lanka. It's a small island in Indian Ocean. And I studied in Ireland and now living in San Francisco. I play basketball, so these are my heroes. And still, I live next to the Levi Stadium, so I follow NFL, and my favorite team is 49ers. And whatever happened with Linkin Park, still 70% of my audio library filled with Linkin Park songs. And this is my family, and this is the new addition to my family. So that's my personal profile, and then my professional profile started as a programmer, and then became an architect, and now working in the CTO's office. But the common thing, I contributed to open source a lot, as well as mainly worked on projects related to distributed computing and middleware. So that's my professional profile. So during this 35 to 40 minutes, what I'm trying to do, tell about this new architecture pattern, and then why we created an architecture pattern, as well as what it is and how we created it. So basically walk you through that story and then share this information. So how many architects in this room, like not the title as an architect, but the role you play as an architect? Okay, so I get invited to a lot of architecture conferences to give this talk. So people, architects come to the room by looking at the title, but I see this kind of a feeling like whether this guy is smoking, because everybody believe the current architecture patterns like microservices architecture, cloud native architecture is well established and then can resolve all the problems. So people question why you guys came up with this new architecture pattern. But actually I was not smoking. We had a really good set of reasons why we came up with this pattern. So first motivation we identified there's a mismatch in between the existing architecture patterns as well as what architects are exactly looking at. So that mismatch was the motivation that we had initially to come up with this concept. And then we realize most of the architecture patterns exist are centralized and layered. So the problem with the layered and centralized nature, when you have different layers, layers create gates, not only at the technical level, even at the team level, there will be gates created, and when you talk to another team and then try to get something done, you have to wait. So as example, if you are a middleware developer, when you talk to the database team to get a space done in a data storage, you have to wait. And then if you talk to the network level people and then get something done, or a kind of punch a hole in the firewall, so you need to wait. So all these layers creating gates, and then that slow down the productivity of each and every development team. So this is one reason that we identify as a mismatch in the industry. Then the second thing, I call it as like PowerPoint architects. Like when you talk to most of the architects, they show nice diagrams, very clean, aligned, very clear. But if you look at the reality, it's totally different. it looks like this because we purchase number of databases, number of application systems, and we are still using it. So it doesn't look like the previous diagram that I showed. So this is the reality that we are facing. So that was another reason that we identified most of the enterprise require this balance of the green field and the brown field. Anybody in the room like completely in the green field? Okay, few, okay. But in most cases, I think we have to deal with the brown field and the green field. And if you look at most of the enterprises, bulk of the data and the systems are in the brown field side, and new projects are getting started in the greenfield end. So the motivation we had behind this, most of the architecture patterns either addressing greenfield or brownfield, and it's really difficult to find something that can address both. So we thought of whatever we are going to introduce should address both spectrums, and then provide flexibility to use legacy systems as well as the greenfield systems like microservices and cloud native applications, so on and so forth. Then the next thing we identified, most of the reference architectures are not reference architectures, those are reference implementations. Why I claim that? Because those architecture patterns define based on a specific technology. Not only specific technologies, most of the architecture patterns are based on a specific vendor, like how you can find a solution or how you can build a solution by using vendor X product N or something like that. So those are very vendor and technology centric. So we thought of it's wrong that the reference architecture should be technology neutral as well as vendor neutral based on your expectations or based on your desired technologies of the things that you are planning to use in future. You should be able to plug those into that particular architecture pattern. So that was another motivation we had during this exercise. Then the second next motivation we had, the underutilization of the technologies, because I talk to a lot of architects, and then when I have this discussion, they say, okay, I have a Kafka broker running, but I can't use it because the architecture doesn't support it. And some people say, okay, I am running a Kubernetes cluster, but most of my applications I can't deploy there because the architecture doesn't support. So it's like you are keeping your best players on the bench when you are losing the game, that these architects couldn't utilize the technology based on the patterns that they were using. Then we found another reason, that there's a mismatch or there's a disconnectivity in between the architecture, development and the deployment. Architect will architect something and a developer will go and develop something different, and the deployment engineer or the DevOps person will go and deploy something completely different, because they don't have something common that they can take from the architecture into development into deployment. So we thought of we need some connectivity in between these three. And then if you look at the new concepts like a full stack developer who's playing most of the kind of combination of these three roles, needs something to connect and take it from the end-to-end application lifecycle as well. So that was another reason we identified. Then the another thing created with the microservices, now you have a lot of moving components, so you need some kind of dependency management, and then not a heavyweight governance, but you need some lightweight governance. To explain this, I think this diagram, most of you are familiar with this, how Uber, the microservices looks like. So when you are building 10 to 100 microservices, you might be okay, but when it grow up more than that, it's really hard to manage. So since you have this lot of moving components, now you need to have some kind of dependency management. So how we can architecturally address that was another motivation that we had. So those were the real reasons behind this exercise. But before jumping to the architecture, let's look at like what kind of architecture patterns we used during last 2 decades. So the first we started with the monolith, like all the user interfaces, business logic and data were together, and then we moved to the 2-tier architecture. With the data improvement of the data technologies, data got differ from the user interface and the business logic. And I think the most interesting era was the 3T architecture. Even I started my career during that time, that we divided the user interface, business logic, and the data. And there were a bunch of sub-patterns came with that. The most popular pattern is MVC and then MVC2, that the really middleware came into the this equation and then started doing messaging in between the user interface and the business logic. And the service-oriented architecture came that wrapped all the business logic around services and the APIs, and then we are moving into a more segmented architecture, that's with the microservice architecture. So what I want to highlight is the layered architecture moved towards more segmented architecture with these patterns that we used during last 2 decades. So this is one, the layered architecture diagram actually I came up with in 2012. So if you are familiar with the layered architecture, usually it's a one-dimensional thing, but we did a little bit different by bringing another dimension with the quality of services and the application lifecycle stages. So this is a very useful diagram that we used to have very productive discussions with a lot of customers or the users, as well as still some of the users are still using this architecture and then building application. I'm not telling it's completely we can ignore this. Some of the enterprises can still benefit out of this. So as I said, this was a very useful diagram, and we did a lot of systems built on top of that. But in 2014, I think, actually 2013, December, we had this issue with one of a larger customer who's based in Seattle. So they were working on full agile mode. The entire process and the teams were operated in a very agile fashion. But the system went into production after 3 years with around 100 APIs, 60 message flows, n number of databases connected, and then they wanted multi-tenancy from day one, and they went into production with 3 active tenants with the first release. But then again, after the project went into production after 3 years, the business rejected the project because, as usual, the business requirements and the the implemented project was not matching the expectations. So we were wondering, now they were following agile principles, operate as a true agile team. So what went wrong? So when we analyze in deep, we identified even they operated as an agile team and then follow the agile principles, architecture was not agile enough for them to be truly agile. So they were kind of following this waterfall agile kind of a concept. So that was the main reason for this failure. So this was an eye-opener for us. Then we thought, okay, it's not only the way teams should work, the architecture should change, and then we had to come up with something that can make these teams productive. So that was the first initiative or the eye-opener for us. The same time, coincident, like the microservices came into the picture as well around 2012. So there were a lot of theory behind microservices came, but we were carefully looking at who's using it and how people are building successful systems. And interestingly, we identified the people who were early adopters of this technology, like Netflix, Uber, so and so forth. They wrote a lot of microservices, but started creating a layer on top of that. So Netflix call it as APIs, and then Uber call it as Edge Gateway, same concept in a different name. And eBay call it as API facade. Even Gartner introduced this concept called a mini service on top of the microservice. So it became a common pattern. And then we walked to the customers who's using microservices at that time, and we identified an architecture like this. So you have the layers, and then you have microservices written. But what happened, microservices became another layer of that same layered architecture, because they have to use other components like the APIs that they are already using, analytics, security, governance, and the data that already flow in the inside the enterprise, and then other tools around that. So this was the architecture that most of these customers were using. So we call it as a more segmented architecture, because what happened with the traditional layered architecture, technically the components or the runtimes were deployed in different layers, but with the microservices approach, people ask permission from that central infrastructure team to have access to portions of different portions of each and every layer for them to deploy the stuff, manage and run. So they use different kind of technologies. Some got like specific spaces, as well as some got like concepts like multi-tenancy used, and then they got a tenant inside this particular layer. So it moved a little bit better than the traditional layered architecture, and we started calling as a segmented architecture. This was one approach. And some of the people, they use a little different approach, that the entire platform duplicated and then deployed for each and every business unit. So some of the things like CI/CD processes and then the user stores and so forth were centralized, but each and every business unit got their own deployment and started deploying the stuff and managing, running inside that their particular space. But still, it was a layered architecture inside each and every segment we had in this particular pattern. So we hit kind of an dead end. Now, it's moving with microservices, it's getting segmented, but still the layered architecture is working on. So we thought, okay, this is not going to work, and then we need to start something fresh and then look different. So we started this project in 2018 February. So I'll tell a little bit about how we came with this concept. Anybody knows this guy? Phil Jackson, okay. So the moral of the story, basically a coach can build better players as well as they can win championships. I think Phil Jackson won 13 championships, if I'm not wrong. So what I did first, got a coach. So this is my coach, he's my boss, our CTO, Paul Fremantle. So I started brainstorming with him how we can build a new concept and then find answers to the problems that we have identified earlier. So what we did, as usually, yes, we did a lot of research and then read a lot of papers, especially published by different universities, and then we read different books. And Paul is based in London, I am based in San Francisco. We did like back and forth trips, did a lot of whiteboard sessions. But most importantly, the exercise we did, we talked to 500 plus customers WS2 is having, and then we asked them what are the real issues that you are facing, and then I try to identify what's really happening in the industry and to have a more pragmatic approach. So those are the exercises we did. Then after that, we narrow down our research into few areas. The first thing is quantum computing. We identified there are really good concepts behind quantum computing that we can use for an architecture pattern. Then we identified Kubernetes got some really good concepts as well, especially when you go for a distributed architecture. Then for some reason, we started reading about biology as well as system biology, because we identified there are some concepts behind system biology and biology that we can reuse in our architecture pattern. So those were the areas that we kind of narrowed down our research. Then another exercise we did, we tried to look at what's the business expectation and the technical expectation of services and microservices, again to look at what's the pragmatic side of the services and microservices that we are writing. So if you look at a service from the technical definition, it's just a set of code that you annotate or use the language capabilities and make it network accessible by using a specific protocol and a transport and a message type. So if you look at the business logic, it's not a big difference that you just annotate it and make a service. But if you look at the business definition or the business expectation from a service, it has to provide a solution for a business problem. So what happened in the service-oriented architecture era, that people started writing different services and they started writing composite services or put a gateway on top of that. As an example, it can be API gateway or a ESB kind of a thing. And then they kind of connect these different technical services and started exposing a meaningful API out of that particular gateway or the composite service to address that requirement of providing a solution for a business problem. So then if you look at the microservices, that's not much different, right? You write some set of code and then you annotate it and make it a network accessible interface. So the difference is basically you divide that monolith service into different parts based on the scope. A lot of people think it's size, but it's not the size, it's the scope. Based on the scope, you divide it, but you provide a same kind of a code in the microservices world as well. So if you look at the business definition, again, the business doesn't care whether you write a microservice or mega service or what kind of a service. What the business cares is it's expecting some kind of a business capability. So as a result, what happened in the microservices world, again, you started writing small services or microservices and then putting the composite services. So that's where the Netflix API comes into the picture, and then the Gartner, the mini services come into the picture, that you connect different technical services and provide a business capability. So that's what we identify what's really happening in the industry. So that was the basic concept of this architecture pattern. Now you have a set of microservices, and then you have a composite service or a gateway on top of it and exposing these capabilities. So what we did, we grouped this set of microservices into a concept called a cell. So that was the beginning, and then that's the building block of this particular architecture pattern. So let's dig in deep into the concept. And so why we name it as a cell? Because we thought cell is the foundation for everything, human beings and then other living stuff. So we thought of that's a really good concept. And even if you look at, and if you are a person who's thorough in biology, in a cell there's something called a membrane, similar to the gateway that I explained earlier, that will control the connectivity, and then it contains different components inside that particular cells, and cells get connected to each other and then provide some capability. So we thought of it's a really good concept that we can map into a technical architecture. So if you go into the concept, the atomic unit in this architecture pattern, we call it as a component. So component can be anything, like any runtime that you run in your data center or in a cloud infrastructure. So it can be a service, it can be a microservice, it can be a gateway, it can be a database, message broker, identity server, whatever that you run in your infrastructure, we call it as a component. So set of components, we call it as a cell, and then cell contains a cell gateway. So it's basically the architecture building block of this particular concept. So I will dig in deep into each and every components, as well as the concept behind the boundaries, so and so forth, in next few slides. So the one thing that we identify, what's the relationship between a component and a cell. In most cases, it's one to many. One cell contains many components, but there can be situations you will have only one component. As example, a database or a message broker, that kind of a shareable component, or even identity server, can go into 1-to-1 ratio, but I would say more than 80% will be one-to-many category that we will get as the ratio. Then how the cells will get connected, because now you have components inside the cell that you need to connect, and then you have a gateway on top of the cell that you need to connect with each and every cell. So we use these common concepts. I think these are like a very popular concept these days, especially with the service mesh concept. But if you are not familiar, then I will use this analogy of a rail track and trains to explain it. So in this concept, you get a control plane. That is basically the signaling of the network. In this analogy, the rail track is the control plane, and then the data plane is the actual the channel that send the messages back and forth. In this case, the train is the data plane, and somewhere you will get a control center that control the train and the rail tracks. So that is basically the management plane. So we use these three concepts while building the communication in between inter-cell communication as well as intra-cell communication. So if you look at in this concept, so if you are familiar with service mesh, it's easy to understand, but this is kind of service mesh plus plus, because you get a control plane and a data plane inside the cell, and then you get a control plane, data plane, and a management plane as outside the cells as well. So we call this the inside cell planes as the local mesh, and then outside we call it as a global mesh. So those are the two components that we get in. It helps to do the communication between components and cells. Then the one rule is all the ingress calls to a cell should come through the gateway. So that's a fundamental rule. But if you are doing an egress call, you can use the patterns like sidecar, adapter, and ambassador. Each and every components will do outbound call, but it will go and hit one gateway in another cell. So the communication will always happen through some kind of a gateway in top of one of these cells. So that's how the cell communication happen, the ingress and egress communication happen in the architecture. Then it's becoming API. It has become an API-centric architecture because the component to component communication happens through some kind of an API, and then the functionality you expose from the cell gateway expose it as API. But it's not only a RESTful API. That we think there are two types of APIs, like the pull APIs, that's the RESTful exposed using HTTP or gRPC, and then the push APIs can be eventing or streaming using different kind of protocols. So one of these type of APIs can be used to expose capabilities from a component or from a cell gateway. So technically it is a more API-centric architecture that you can communicate in between cells as well as components. Then the gateway pattern is key here because it helps to enforce policies, because as I explained earlier, even you do a egress call from a component, it will go and hit another cell gateway. So you can put policies at the gateway level, and as a result you get observability automatically, because you can enable observability at the cell gateway level and then start capturing information and feed into a observability layer. So those are the advantages that you are getting by using this gateway pattern. Then the security of a cell, the two folds. First thing, some cells can be self-managed, like all the secure tokens can issued by particular cell within the STS inside the cell. But in most cases, the STS inside the cell that remains in the control plane of the cell will go to the global control plane, and there will be a IDP at the global control plane and get the additional information required to make a authorization, authentication decision within the cell. And to optimize the performance, you can cache most of the decisions within the cell. So that is how this security works in the cells. I think this is the area that we have to get in detail. So I am working with one of the security architects to publish another paper on cell security, and it will be available soon. So that's where the security goes. Then the developer experience of a cell, because that's the key, like it can come as architecture pattern, but developers, they have to be productive in this pattern. So we identify different kind of scenarios. First thing, a developer might start a brand new cell and start adding components to that. But in most cases, if you have a set of microservices, you will pick those services, group them, and then put it into a cell. And if you are not using a container-based system, you might have to update the cells. But in a container-based environment, what we tell, those are kind of immutable cells that you always deploy a new one and then remove the existing cell. And there will be situations that you need to create a new version of the cell, because if the existing cell is used by some consumers, you need to deploy a new one. So all these patterns can be supported. Then the developer will not feel any difference even they adopt to the cell-based architecture. What they will do, they will go through the usual developer flow. You code, you test, you commit, and I think that's the fun of programming. that you will go through that cycle, and once you check in something that is ready to deploy, CI/CD will kick in, and it will deploy a component into the cell. If you are deploying a component into the cell, then you will call the control plane inside the cell and signal. If you are deploying a new cell, then you will tell the global control plane and then deploy it into the environment. So if the organization CI/CD process is not mature enough, then it can be a human who will do that role, kind of a release engineer who will run some kind of a script and then deploy it into the environment. So what I want to highlight, the developer life will remain same. He or she will not feel any difference, that they will go through the same development life cycle and then start deploying it. Then the life cycle of a cell. Now I briefly explain, you can deploy a new version. So the cell will contain its own version, and each and every component inside the cell will contain its own version as well. Depend on the maturity of the cell, you will run cells in different environments, and you will run different versions of the components as well. It's totally depend on where does this cell remain in the application life cycle of that particular system. So that will help to deploy like blue-green deployments, rainbow deployments, as well as canary deployments, because you have the cell version as well as components version in this pattern. Then that creates that we call as a structured agility, because the components got its own version. You can be iterative within the component, and then since the cell got its own version, you can be iterative at the cell level, and then you will get the agility at the global or the enterprise level as well. So 3 levels of agility you get because of these versioning concepts that we have incorporated into the architecture. So now it's about component cells, but individual cell or a component doesn't help to build a system. So how the enterprise architecture concepts will apply to this will be discussed during the next few slides. So this is what we envision, or the systems that we have built looks like. A bunch of cells running internally and a bunch of cells connected externally. So how the internal and external separation happens? So we call, based on the ownership of the data, we call whether it's an internal cell or an external cell. So if you own the data, then it's an internal cell, and if you don't own that particular data set, then it's an external cell. So that is how we categorize this stuff. And then if you see, there are the end user application cells at the top, and then some external cells. So we identify a bunch of categories of cells. So the first category, we will call it as a logic cell. The microservices, services, and gateways, those kind of things that apply some logic will go into the logic cells. And all the composite services will go into the integration cells. And then you have a lot of legacy applications, then those will categorize into legacy cells. Basically, you wrap the legacy services from a service or a gateway and then expose them as API and then make it a legacy cell. Then you have connected with SaaS applications and with your partner applications that is out of your control. So you call them as external cells, and then data cells and identity cells are there. The channel cells are the end user applications that end user will access. So it can be a web app, IoT application, or a mobile app. So those are the cell types we identified based on the current implementations that we have done, but it can evolve in the future as well. Then I put a reference implementation. So this is basically example that you have a employee cell that connect with the database, and then with some external systems. Then you have an order cell that connect with the order management system, and then you have a customer cell that connect with the CRM system, so and so forth. So it's kind of depend on how your organization structured, and depend on what kind of functionality that you are providing to your outside world, you have to define the cell boundaries, and we have defined some set of rules how you can identify or define the cell boundary. And again, we are working on a paper that that will kind of guide you to define the cell boundaries based on the functionalities and parameters that you are passing into that particular logic. But domain-driven design is one concept that you can use, but then again, domain-driven design doesn't apply completely here because it's done based on object orientation. That's kind of a little too low level to have this kind of a concept, but it might be a good start if you are planning to design yourself. So now this architecture doesn't have any implementation details. So what we did, we mapped into set of implementation. So I used some WSO2 components in this architecture, as well as things like Spring Boot, Nginx, and then this new language we introduced called Ballerina. I'll go in detail in the different slide. And then it can be on Kubernetes or Amazon, VMware. So what I want to highlight is it's not specific for any technology. Based on different based on your technology choice, you can map those technologies into this architecture and implement it. So this is a one implementation. And if you look at the channel cells, they are using different technologies to implement the end user experience. So it's more kind of a human-centric architecture. Why I claim that? Now in Agile principles, you have these Agile teams. Now you have a building block for this team to use a cell. So basically the rule here, a cell can, a team can own multiple cells, but a cell cannot be owned by multiple teams. So it's not a shareable thing. One team design, they build, they test, they run, and they manage a cell or multiple cells and expose the functionality through an API to different teams. So that's where it's more kind of a very human-centric approach that we have used here that gives more agility to this Agile team to use these architecture concepts in their development. So now, as I explained earlier, the business will not care, right, whether you use a layered architecture, microservices architecture, or a cell-based architecture. So we identify a few things, like once you start using this particular architecture pattern, how you can show the business there's an impact. So few KPIs. First thing is the layered architecture looks like that because your wait time will be higher than your productivity time. So what the main change happens with this architecture pattern, you will minimize the wait time because you are using cells inside this particular team. So you can show the flow efficiency that will improve a lot by minimizing the wait time. That is one KPI. The second thing is MTTR, or the mean time to repair, that since the cells are completely independent from each other, you can quickly fix a bug and then release a new version, rather than you wait to release the entire new version of the system. So you can show some improvement with the MTTR as well. So those are two really good KPIs that you can show the business, okay, we have improved and we are more an Agile team before compared with the architecture that you used before by using the cell-based architecture. So those are two KPIs that you can use. Then in summary, like it's self-contained architecture block, and then you can deploy it as a unit, and then you can scale it independently. You can scale the things at the component level, and then you can scale it as cells, so on and so forth. And it has a data control and a management plane. So that is kind of a summary of a cell. Then we did some projects around the cell-based architecture because we didn't stick to the concept, because you need some frameworks and tools to build this architecture. First thing we did, okay, we published this spec in GitHub, and then we identified it's really hard to just implement the reference architecture. You need a methodology. So we authored a methodology around the cell-based architecture, how you can apply it to the organization. So it followed the same principles like people, process, and technology, but we extend it a little bit that we identify culture and the architecture is the foundation. And then once you improve people, process and technology, you get a better digital alignment. That is what we explain in this methodology. Then we introduced this new project called Cellery. Cellery is basically a reference implementation of cell-based architecture targeting Kubernetes. In future, we are planning to target other infrastructures, but this project is mainly targeting Kubernetes. Basically, it has 3 layers. You have a management layer that you can monitor, trace, and secure this stuff. And then you have a runtime layer that is that contains with Kubernetes, Istio, and Cellery runtime. And then you have the developer or the dev layer that you define all these cell descriptions and push it to the runtime. So if you go to cellery.io, you can download this project. Then some example code. So it's basically infrastructure as a code that you write your cell definitions, and then you get the visualization of the cells of what are the components running, and then you can get the dependencies, so and so forth as well. So that will give a graphical parity of what you are deploying into the infrastructure. So we are using a couple of Kubernetes concepts. This is a CRD, cell is a CRD, and then component is a pod, so and so forth. So we wrote a custom CRD to represent a cell, and then we are deploying it to Kubernetes. So then we released a 0.40 version recently that contains a lot of new features. And this is how it is using Kubernetes concepts internally and utilizing it. As I said, CRDs are the representation of the cells, and we have the global control plane and then control plane and management planes inside each and every cell as well. Then another project we did around this called Ballerina, a new programming language. So the usage of Ballerina in the cell architecture, basically you can write components, microservices, integration microservices, and gateways using Ballerina. And the beauty of it, so we were working in the middleware sector from 2005, especially when the service-oriented architecture started. So we believe the middleware is shading away to code and infrastructure. So address the code side of this story, Ballerina come into the picture. Basically, the middleware is embedded in the language, so you can write services and integration scenarios quickly using the language. And beauty of the language, you have the code and the graphical parity. Once you write a service or an integration microservice, you can get a sequence diagram generated. And then you can change the sequence diagram and change the code as well. So that is the beauty of the language, because if you are an integration engineer, it's really hard to represent the integration flow. Data flow is what we use for a long time, but data flows are not that great to represent a messaging flow. And then you can use Ballerina as a infrastructure as a code as well, because in infrastructure as a code level, what we do is a lot of integration. So the Ballerina language is optimized for integration. It's another use case that you can use. If you are interested, then you can go to ballerina.io. That's a website to download this stuff. So what I want to tell you, kind of invitation to consume and contribute. So those two specifications, the reference architecture and the reference methodology, we released under Creative Commons. And these two projects are released under Apache. So the specifications, we want to make it kind of a community project. That's why we release it in GitHub and as Creative Commons. So if you need, if you think there are any modifications or any new suggestions, you can send a PR. We are welcome PRs. And if you like the concept, yes, you can give a Git star as well. And other two projects same, you can do contribution as well as you can consume them, because Apache 2.0 is a very business-friendly license that you get. Then I think usually people end their talk with the external quote. So I picked one of the tweets that I did some time back, because anyway, end of the day, what we are doing is a digital transformation to the organization. So I believe the digital transformation is basically internally and externally improving the user experience. To do that, you need a very human-centric approach. As I explained earlier, cell-based architecture is a very human-centric architecture that we are addressing a lot of technical problems, infrastructure level problems, architecture level problems, but more than anything, these human problems that we have in teams and how an agile team can be productive. So that's all I have, and these are my contact details, and if you are interested on implementing this architecture, we are happy to help. I'm providing some consultancy around this as well. So if you are interested, please contact me. We are happy to help. And as I explained earlier, if you have any suggestions, send a PR, and then if you like the spec, send us a Git star as well. Yeah, so I think it's helpful. If you have any question, I think we are on time. If you have any question, I can take few when I am around. If you need to talk to me, feel free to come and talk to me.